The world lives on oxygen. Without oxygen, nothing can survive. This is a fact which nobody can deny. But nature has its own way to surprise us. Welcome to the 7th episode of Wastewater Connect India. In this episode, we will talk about a process where oxygen is not required at all, the anaerobic process. This mysterious yet prominent process is useful as it produces byproducts which are used in various fields. The anaerobic treatment is a biological process in which microbes degrade biodegradable matter in absence of oxygen. The result? Cleaner water and a useful byproduct called methane and carbon dioxide. The anaerobic treatment consists of 4 stages. The core stages includes hydrolysis. This stage involves breakdown of complex organics such as proteins, carbs, and fats into simpler soluble compounds. Second stage is acidogenesis. This involves conversion of simpler soluble compounds into VFAs, alcohols and gases. Third stage is acetogenesis. This involves conversion of VFAs into acetate and hydrogen gas. And the fourth stage is a methanogenesis stage where methanogens convert acetate into methane gas and carbon dioxide. This process cuts energy costs, reduces sludge volume, and recovers energy, making it sustainable choice for high-strength COT. Controlling an anaerobic bioreactor is like piloting a submarine. Subtle changes lead to big serious consequences. Let us explore some operational parameters which are necessary. First is COD load. The ideal rate should be between 2 to 15 kilograms per meter cube per day. Second is pH. The rate should be between 6.8 to 7.5 as methanogens are very pH sensitive. Third is temperature. If you are having a mesophilic system, it should be between 30 to 38 degrees Celsius. And if you are having a thermophilic system, it should be between 50 to 55 degrees Celsius. Fourth is VAPs or alkalinity, which should be less than 0.3. Fifth is ORP, oxygen reducing potential, which should be between minus 200 millivolts to minus 400 millivolts, which acts as a stability indicator. There are various types of anaerobic systems or processes, each depending upon the type of influence and industries, such as UASB, that is upward anaerobic sludge lacquer, CSTR, that is continuous stir tank reactor, EGSB, that is expanded granular sludge bed, anaerobic filter, and a hybrid one which includes combination of few of these. But today we will be focusing on UASB, which is the most prominent one. The UASB. In this process, effluent flows upward through a blanket of granular sludge. The granules trap organics, the microbes degrade it. Biogas forms in situ, induces recycling and formation of sludge. The GSS or the gas liquid solid separator at the top removes biogas and recycles sludge. This type of process is very efficient in high to medium strength COD effluent. Now we will move towards some of the common problems we faced in UASB and how to troubleshoot them. First is log stacker length. Season emptying anaerobic sludge. Maintain temperature using thermofilling jackets and water bath. Start with low COD load and then gradually ramp up. The second persistent problem is toxic shock or pH crash. Modern symptoms: sudden drop in pH, rapid fall in biogas production, foaming or floating of sludge, accumulation of VFAs and sulfides leading to SARS-berry, drop in MLSS MLVSS levels, increase in BOD COD levels at the outlet. How to fix it? Install equalization tank upstream, do sodium bicarbonate or lime for buffering, pause feed temporarily, and if solid persists, reseat. Last but not the least, add activated carbon in case of emergency. The fourth and one of the most prominent problem is sludge washout. What will be its root causes? First is excessive hydraulic load or high upward velocity. Second is poor biomass retention. Third is weak granular formation. Fourth is low MLSS, and fifth is sludge bulking due to low settlability. Now how to fix it? Reduce the upward velocity immediately. The ideal range should be between 0.6 to 0.9 meter per hour. For proper granule formation, dose with ferrous and magnesium salt. The concentration for ferric salt should be between 10 to 30 milligram per liter, and for the magnesium salt, the concentration should be between 10 to 50 milligrams per liter. Improve HIT and biomass concentration. Third is phobic or scum. Foaming is primarily caused by filamentous bacteria, excessive fats, oils, and these surfactants such as soaps and detergents, protein-rich wastewater, unbalanced nutrient supply, and sludge with poor settling qualities. How to fix it? Use mechanical foam breakers or surface sprays. Avoid overloading of protein. Limit the discharge with proteins less than 300 mg per liter protein equivalent. Also, check nutrient balance and FOG. Imbalance impacts. If you are having low nitrogen or phosphorus or excessive of FOG more than 50 milligrams per liter, filamentous bacteria grow. Anaerobic systems are best suited for high COD, warm and biodegradable effluents. You will find these systems in distilleries, starch industries, pulp and paper, slaughterhouses, dairy and cheese industries, etc. These industries treat their effluent and produce biogas which they use in-house as clean energy source. Biotreatment anaerobic digestion is a climate smart technology. It cuts electricity consumption by 90% as compared to aerobic system. It produces biogas. It reduces sludge production and it supports ZLD and carbon neutral goals. The information and the parameter range we shared in this video depends upon the ideal conditions. They may vary depend upon the different kind of variations and conditions on field. I hope that you like this video. If you want a personal consultation or detailed information, mail us or call us. Follow Wastewater Connect India for more such videos.